Okay, so you've probably heard that we could power our world many times over with the energy of the sun, but what is holding us back? Part of the problem is cost. A perovskite solar cell has the potential to be more efficient and thus provide cheaper electricity. These perovskite solar cells need transport layers between the perovskite material and the metal wires in order to work, and it's these layers that we study in our laser lab. I'm going to try to explain how it works with water. Fingers crossed. In the solar cells use semiconductors, and the free electrons in the semiconductors can be in states which are either low energy or high energy, but not in between. These bands of states with different electric potential are represented by these two tanks at different heights, so water with different gravitational potential. Electricity is the flow of electrons from high potential to low potential, just as water flows down a hill. In a solar cell, the electrons in the low band absorb the energy of the sun and excite it to the high band. They will naturally want to relax down as water flows down a hill. And this can happen within the perovskite material itself, but we instead want our water to flow out and through a circuit. So we need to connect a loop of wire. This loop of wire has two connections on either side because electrons in either band can flow into the wire. But as we know, water flows downhill, so it flows from the high band down to the low band. Now with just the loop of wire, we can see there's equal flow in both directions, so there's no net current. So in order to get net current, we need to add our transport layers. On one side, the transport layer allows electrons to flow out of the high band and in the wire. On the other side, it blocks the flow of electrons out of the high band. And this way, we get flow in just one direction. In our lab, we try to measure the flow of electrons through these transport layers in order to find the best material. We use a pulse of laser light to pump the electrons up, and then we use a pulse of terahertz radiation to detect the excited electrons. Each pulse is a snapshot, and we take snapshots at 1 trillion frames per second in order to see how fast the electrons move through our transport layers. So, by researching better materials for the transport layers, we hope to make perovskite cells more efficient and thus provide cheaper electricity. Thank you.